everybody, welcome to CodingNomads Java A to Z Fundamentals Speed Training in 90 minutes. You might be thinking to yourself if you signed up to this earlier, wait, I thought this was 60 minutes. Well, you're right, it was. And when we recorded it yesterday live, it went a little bit over, closer to 90 minutes. We did our best to keep it to 60, but it went up to 90. So we're going to split it into three chunks, three 30-minute videos that go through Java Fundamentals A to Z. And then we'll have a fourth bonus video where we create a Blackjack poker game using the skills we've just learned. So moving on, who am I? My name is Ryan Desmond. I've been a Java developer for about 10 years. I've spent about half that time teaching others Java. I created the curriculum at CodingNomads, the Java curriculum, based on what I've learned in my career and kind of what I think. There's a lot of information out there. There's so much information, and not all of it is necessarily equally as important, especially when you're just beginning. So I've created this curriculum to help people get comfortable and productive with Java as quickly as possible. In this webinar, I'll be going over the fundamentals of Java, and this basically covers what our current online introduction to Java online course. And you'll also be getting a quick peek at our new online learning platform, which we're very excited about. It's not yet publicly available, but we are extending invitations for beta users to join the platform at a discounted rate. So if you're interested in that, my contact information will be at the end of this video, and feel free to reach out. So why are we interested in learning Java? It's simple, really. It's the #1 most in-demand language around the world. It's the #1 most widely used language around the world. And it's a great first language to learn. There's several reasons for this, but primarily it's because Java is what's known as a verbose and strictly typed language, and it enforces all of these rules and best practices that some of the other languages, although a bit easier and potentially more concise to write, kind of ignore or skirt around. And so if you're learning Java first, or if you already know another programming language, no worries. But if you're learning Java first, it's a really good foundational language that gives you this wide breadth of knowledge and makes it maybe potentially a little bit easier to learn other languages later. And at CodingNomads, we're proud to teach Java because we're one of the few boot camps that do. Quick note about our upcoming courses. We have both Java, 16-week Java intensive and Python intensive starting February 18th in Ubud, Bali, which is very exciting. These are 16-week courses. The first month is entirely online. It's a prep course. It goes through the Java and Python fundamentals. The following 2 months are spent in Ubud, Bali. It's full-time, 9 to 5, Monday through Friday kind of schedule, lectures in the morning and coding in the afternoon. And it's going to be super fun, super productive, and seats are already halfway sold out. So also, if you're interested about joining one of our in-person courses coming up, just reach out. Feel free to reach out. Graduates of our program have become funded startup founders, junior Java developers, or they've moved into more technical roles in their current companies or careers. And we're very proud to be able to say that our students now work at companies like KPMG, Marketo, Experian, Philips, Universal Robots, and Enterprise Engineering, and many other places. So super cool stuff. And now let's jump into what we're all really here for, which is Java Fundamentals A through Z. I'm going to be using our new online platform as a bit of a guide as we go through this. Like I said, this is brand new. We're very excited about it. As it says right here, we're still under construction. So this is basically our old CodingNomads website, but completely upgraded. And now you can log in, and all of our Python, Java, we also have a JavaScript web development course material is behind this login. So you can come in and start learning immediately online, which is really neat. So I'm going to be using the Java course here. And the way that we break this down, the goal with all of our courses is to make everything as simple as possible. Break it down, basically, here's what you need to know, bullet point, bullet point, bullet point. And we try to do that with a little bit of documentation, a little bit of video, and a little bit of challenges. So for instance, you can see we've got some documentation on code blocks, a video on understanding variable scope, and then a quiz or a coding challenge. And at the end of each section, we've also got a bunch of questions we ask you to answer and labs that we ask you to complete and push to GitHub and so forth. All of our online courses come with personal, dedicated one-on-one mentorship to help you move through this as rapidly and efficiently as possible. So you'll see me coming back and forth through here a little bit to make sure I stay on track. So the first thing that we need to talk about with Java, it's officially, okay, got the time. The first thing that we need to talk about with Java is the JVM. And I'm going to speak to it really, really briefly, but you hear it all the time with Java, that the JVM, and the JVM stands for Java Virtual Machine. And basically all that is a virtual machine that runs on your computer when you install the Java runtime environment or the JDK, the Java Development Kit. And it interprets the bytecode that gets produced when one of our Java applications is compiled into machine code. So Java, as you may have heard, is a compiled language. It requires a compiler, and it takes the code that we write and it converts that into what's known as bytecode. And then the JVM takes that bytecode and it converts that into machine code. And the reason why it does this and why the JVM was such a useful invention is that it allowed Java to be what's known as written once and run anywhere. So you can write code in one language, take it Java, and run it on any CPU out there. And in the mid-90s, when Java was first coming around, and still to this day, that wasn't necessarily an option because computers had to be compiled to work on each individual CPU. So the Java virtual machine basically solved that. It continues to be a very, very useful thing because it just helps keep our programs contained, and it stops any adverse reactions from happening or adverse events from happening outside the JVM. So somebody could write malicious Java code to try to do something on, someone's computer or server or browser or whatever it might be, and the JVM will actually stop that from happening because it's a contained environment. So that's the JVM, and we can come back to that. But one thing I say about the JVM, it's good to know. The more you know about it, the better. But if you're trying to learn how to drive a car, you don't need to learn how to build an engine first. And so it's good to know about the engine, have general understanding about the engine, and it's kind of that way with Java and the JVM. In order to become a good Java programmer, it's good to know about the JVM and how it works, but you don't necessarily need to be a mechanic in order to drive. So moving on to the fun stuff, I've created a project here that we're going to be using through this webinar to kind of guide us through, and I'll be sharing all the source code with you. Real quick, before we even jump into the IDE, I actually want to demonstrate to you guys that running Java applications can be quite simple because these IDEs like IntelliJ can be, and large applications, lots of files, they can get kind of overwhelming. So let's just take a second to look at what it really takes to run a Java file. So I'm just going to go create a new directory. Doesn't already exist, and I'm going to cd into there. I'm on my command line interface right now on my computer. Java files are just text files, so we don't need, as long as you have Java installed on your machine, you can run these Java, a Java application, no matter how small it might be. So let's just demonstrate how we do that here real quick. So I'm just going to say Vim. Vim is a text editor for the command line interface, and this is going to say hello world.java. And I'm going to say class hello world. That defines the name of the class, which we always like to have in a file of the same exact name. So the class hello world would be in a file called hello world.java with the same exact spelling, capitalization, everything. Classes too in Java, the first letter is always capitalized. I'm going to create a very simple main method, which I'll explain to you a little more shortly. And this method, the main method is basically what the JVM will look for by default as where it should start the application, basically the entry point of the application. And all we're going to do here is just say system.out.println hello world. And hello world is a very famous kind of first application that everybody writes. And then I'm going to go ahead and quit that. And if I go, I can open hello world.java. This is just a text file. You could open it with a text editor, with anything else. I wouldn't use Microsoft Word or anything like that to do it, but just a text editor or with the command line. And now from the command line, I can compile that. So Java C hello world.java, and that compiled it. So now if I list everything in this directory, you'll see that I've got hello world.java, which is what the file that I wrote, and hello world.class. And hello world.class has the bytecode, and the bytecode is what the JVM will actually execute on your computer. So to run it now, I can just say Java hello world, and it printed out hello world. So it can be that simple. Java applications, programming languages don't need to be that complex. You can just think of it as a simple text file that's going to do some stuff. As they get more complex, it's a number of text files that all kind of work together to do something. And we're going to explain that here very shortly. So now let's go back over to the IntelliJ IDE. IntelliJ is my personal favorite. It's generally kind of, one of the most widely used integrated development environments out there. And instead of saying integrated development environment every time, we just say IDE. And it basically just helps us write code faster and better. It's got things like autocomplete, and you can right click and run, and there's just all of these really useful things that make it much more useful and productive to write our code here in an IDE rather than in a text editor. But we could do everything in a text editor if we wanted to, and some people still do. I would advocate strongly that you use an IDE. So the first thing that we need to learn about with while learning Java is, primitive data types, variables, operators, flow control, and conditional statements, and some data structures. So again, that's data types, variables, operators, flow control, and conditional statements. What I mean by that is if statements, for loops, while loops, and data structures, arrays, and array lists. So let's go ahead and just hop right in. Data types and variables. I am going to do, just so you know, I'm going to do everything in a main method. In IntelliJ, for instance, one of those shortcuts, I can type PSVM and hit enter, and it'll auto fill out my main method. Again, a main method is what the JVM will automatically look for to start the application. So when I try to run this application, the JVM is going to look for a method called main and then invoke it. So when we're getting started, all of our code will start in a main method. You can change this later on, but we don't need to worry about that now. So let's talk about data types. In Java, we have 8 primitive data types. And in Java, there are 2 types of data. We have primitive data types and we have object data types. And we'll talk about objects in part 2 of this speed training. So right now, we're just talking about primitive data types. And primitive data types are called primitive because their value can be stored in a single string of bits, like 0, 1, 0, 1, 0, 1. And come up with a value. So it's not kind of an abstract concept where you might have different pieces of information in various different parts of memory that all create one understanding of an object, for instance, and we'll come back to that. This is just, for instance, the number 16. I can write that in binary, I can store that in memory, and that's a variable 16. So speaking of 16, that's an int. So I can call that int I equals, or let's just stick with int I. So this is me declaring a variable called I of type int. Ints are kind of your most common day-to-day integer when you don't, it's a round number, meaning it doesn't have any decimal points, right? If you want to use a decimal point, you'll almost certainly be using a double. And a double is for a number like 10.123 or 7.14 or 3.1412, etc. Another decimal type is float. I'll hold off on giving these any values yet. So a float is a floating point precision number, and it's actually half as big as a double. So a double is 64 bits, and a float is 32 bits. And that just means how big of a number can they hold. In 64 bits, you can put a very, very, very big number, because if every one of those bits is turned on, I don't even know what it is, but it's very, very big. And a float can be half that big. And so it's called float is called floating point precision because it has decimal points. And then a double is called a double because it's a double floating point precision. It's got twice as much precision as the float. Some of the other ones we have are char. So char is for characters, just a single character, like the letter A, which if I open up an ASCII chart, I think it's uppercase A is the number, corresponds to the number 62 or something like that. So if we want to store a single character, we store that in a char. We've also got Boolean. Boolean is just true, false. So a Boolean is in binary would just be a 0 or 1. Is this on or off, true or false? Some of the other ones that we have, but we don't necessarily use them as often, are byte, B, and this is just an 8 bits. So let's say I'm making an application where all I'm going to do is track the days of the month and the months of the year. So my days are never going to get higher than 31. My months are never going to get higher than 12, if you're using the Gregorian calendar. And I don't need a double 64 bits worth of memory to store the number 12. I never will. It'll never be necessary. So we don't need to use a double. We can just use a byte. This is where Java kind of, let's give this another byte Z. This is why they call Java a strictly typed language, because it's strict in that it requires you to declare what type of data you're dealing with. And so this is what we're doing right here with our primitive data types, is we're declaring I is of type int, X is of type double, F is of type float, C is char, B is Boolean, Z is byte. And then we've also got short. Short is 16 bits, so it's twice the size of a byte. What am we missing here? Int, double, float, Boolean, char, byte, short, long. So long kind of goes with int. It's for whole numbers, round numbers, meaning no decimal points. And it's just bigger than an int. So if you need to store a very long number, that would be of type long. And then we've got float and double, which are let's say decimal point numbers. Char is a single character. Boolean is true or false. Byte is 8 bits. So like the largest number that it can hold is 126 or something like that. And then a short is 255, is 16 bits. And those are our primitive data types. Twice as big as the float. And the most common ones we use by far are int and double and Boolean. Anytime you just have some number like 74, 62, whatever, 312, whatever it might be, it's an int. And then I'm not sure particularly why, but everyone seems to use doubles all the time rather than using floats, myself included. So you'll see lots of ints, lots of doubles, lots of Booleans, an occasional char, an occasional long. Bytes and shorts and floats are a little more rare. So those are our primitive data types. Now let's talk about variables. So all I've done here is I've declared these data types. Well, I've declared these variables, but I haven't initialized them. So let's go ahead and initialize them. So int I equals 10, long L equals, give that some big long number. I put that L on there to tell Java that this is indeed a long, not an int. Float F equals, let's say that. Again, I'm going to put an F on here to tell Java that this is indeed a float, not a double. That's a little funny, but and then another decimal point here. Char would be, for instance, C. All chars are wrapped in single quotes, unlike strings. So string is basically like a string of characters, meaning a word or a sentence or a book. A book would be a very long string, but a sentence, etc. A paragraph is a string, and they're always in double quotes. We'll talk about that more. But a single character is always in single quotes. If you put it in double quotes, it'll be an error because incompatible types, it required a char, but it found a string. So single quotes always on chars. Boolean, let's start with true. Byte, what was the biggest number here? Maybe 120. Yeah, 127 is the biggest number for a byte, and 256, 57. Somewhere up there is the biggest number for a short. But nevertheless, let's go with 256. Now what I'm looking at here with all of these are variables. And they're intuitive. It's a variable. I can say, for instance, I equals I times 10. And then I'm going to go ahead and say SOUT, S-O-U-T in IntelliJ, hit enter. Is just a shortcut to print out or to give a system.out.println, which just prints something to the console. So I'm just going to print the value of I is, and then I'm going to add on that. I'm going to concatenate the variable I onto this string. And then I can right click anywhere on the screen and I'm going to say run datatypes.main. It's going to compile here for a moment. And you'll see the value of I is 100. But the value of I started at 10. But it became 100 right here when I said I equals I times 10. So those are data types and variables. I don't need to belabor the variable point too much. I think it's pretty intuitive. When you need a true or false variable, use a Boolean. When you need a variable to hold the number 16, use an int. When you need a variable to hold the number 3.141, 3.1214, use a double, so on and so forth. So what happens when you have let's see, data types of variables. What happens when you have one type of variable that you need to change into another type? So for instance, and this just happens, like you've got a double, but you need it to be an int for some reason, or you've got an int, but you need it to be a double. That's called casting. So casting happens all the time. And there's implicit casting. So when something can just automatically convert into something else and you don't need to do anything. And then there's kind of explicit or overt casting, where you actually have to physically manually cast it. So let's say that we have this int I equals 10. And I'll come back to scope in a second. Int I equals 10, and then I'm going to say double x equals I. That works, right? Because an int can fit into a double. And this is just a kind of a new thing to think about, but an int can fit into a double, meaning that, but it's not, the inverse is not true. A double cannot fit into an int. Why? Because ints don't have decimal points. They can't have decimal points. So if I had the number 3.1412, there's no way I could put that in an int. That being said, if I have the number 3 as an int, I can put that number in a double. So this is called implicit casting. It just works. I said int I equals 10 and then double x equals I. That works. That being said, I cannot say double a equals 1.23 and then int b. I should probably just come up with the standard here. A, B, C, D. Again, these are just the names of the variables. The name is A, B, C. I cannot say int D equals C. Why? Because this is what's called a narrowing conversion. Information will be lost, right? I'm going to lose the 0.23 if I try to put that variable C into this variable D. So what I have to do is I have to cast it. And the way that I cast it is I say in parentheses right before on the side with the value that I'm trying to assign onto the variable. So on the right side of the equal operator here, assignment operator, I have to put the type of variable that I want C to become. And I want C, which is currently a double, to become an int. And I want you to put that int on D. So now if I print out D, you'll see that it'll print out the number 1, not the number 1.23, because D is an int. This works for up and down the board. So widening conversion, so a byte can become a short can become an int can become a long can become a float, I think, an int can become a float can become a double, and so on and so forth. But the inverse is not true. A double cannot become a float cannot become an int cannot become a short cannot become a byte, because it's a narrowing conversion. And when you're casting, you just got to do it like this. You just put, when you have a widening conversion, you know you might lose data, but you're okay with it. You can cast. And that's by just putting the name of the data type that you want it to become right in front of it. Okay, so let's check in here. We have primitive data types, variables, we're into operators. Okay, we got some ground to cover here in about 12 minutes. So let's talk really quickly about variable scope. No, actually, I'm going to punt on that until we talk about flow control, if statements, while loops. So let's look at operators. Again, I'm just going to make a main method so I can quickly run this. Operators are basically saying int I equals 10, int x equals 20, int z equals I plus x. So I've used the assignment operator, which is the equal sign. I've used the addition operator, which is the plus sign. I can also say, for instance, z, now that I've declared z, I don't need to say int z again. It's already declared. So now I can say z equals z minus I, right? And or I could say z equals z over I, or times I. All of your kind of arithmetic, geometry, not geometry, but basic arithmetic, plus, subtract, multiply, divide, they're all there. You can use them just intuitively like you think you would. One interesting operator is called the modulus operator. So here I'm going to say int mod val equals, let's say 10 mod, which is the percent sign, 3. So what mod does, the modulus operator, which is this percent sign, is it gives you the remainder. So 10 divided by 3 is 3, and with a remainder of 1. And so if I print out mod val, again, it's going to print out 1 because the remainder is 1. So a very easy way to check if a number is odd or even is to mod it by 2. Because if you mod an odd number by 2, the result will always be 1. And if you mod an even number by 2, the result will always be 0 because there is no, 2 divides into every even number equally. There's also these green arrows, just so you guys know, on IntelliJ. Anytime you can use them to run the most recently run application anytime you want, or you can just right-click anywhere and run. So other operators. So we have, these are just kind of like regular operators. Plus, minus, divide, multiply, modulus. Then we've also got what are called relational operators. So relational operators are is I, and I'm going to have to throw, well, this is a good transition to flow control, but I have to kind of throw in an if statement here. If I is less than 20, sout I is less than 20. For instance, if I run this, it'll print. These are called relational operators. We've got less than equal to, we've got greater than equal to, we've got equal. So if we put the equal sign twice, that means is this equal to? It doesn't mean I gets the value of 20. So here the equal sign means I gets the value of 10. X gets the value of 20. This is saying is I equal to 20. It's a Boolean condition. One more type of operator that we should mention here are called logical operators. So logical operators are and, or, and not. And, or, and not. And the way we use those is, for instance, you can say if some condition and some other condition are true, or if some condition or some other condition is true. So let's take a look. So if I equal 10 and x equal 20, then print out, for instance, I equals 10 and 20, x equals 20. You can do or, so if, which is a vertical bar or pipe. So this says if I equals 10 or x equals 20. And then you can do not. We'll come back to not shortly because I'm going to show you guys the short circuit operators. So when I do and twice, this means so and means I must equal 10 and x must equal 20 in order to print out this line. If I do the short circuit operator, which just means adding a second and symbol, that means that if this one validates to false, for instance, if I equal 11, that's false right now. I is equal to 10. It will not check the second condition because it's already failed the general overall Boolean condition, which is that both of these things need to be true. So for instance, this will pass and it will check both conditions now because this is true. Okay, this is true. Let's also check this. This is true. Good. Let's print this one out. With the or, again, you can do a single or, which will check this, if this one is true or if this one is true and go in. You can also do the short circuit operator here, which will basically say if this first one is true, it doesn't need to check the second one because the general Boolean condition of one of these, one or the other being true, has already been satisfied. And I should also mention there's one more called XOR, which is exclusive or, which is a up caret like this, which means this one can be true or this one can be true, but not both of them. It's an exclusive or. So those are our logical operators. Just to put those in here, we'll say and is the short circuit. We've got or is the short circuit. Not, so just to show you not, is basically just, for instance, x not equal 20. And we can also do other things. For instance, let's say I had some string like, string s equals hello. Then I could say something like if not s dot, and I'm jumping ahead with this s dot equals, so here I'm saying s dot equals hello will return a Boolean condition, and then I'm saying not, so the opposite. So if s dot equals hello is false, if not s dot equals hello, then print this out. But that's come back to that. So the primary ones you need to know right now are, for instance, if I equal 20 and x equal 20, so that's actually I equal 10. Then we can use the short circuit and or short circuit or, as well as the exclusive or, meaning one can be true but not both. That's logical operators. And that's operators. Let's make sure I didn't miss anything here. Java operators, flow control. Okay, let's get into the flow control. So I'm going to do these real quick. I'm going to start with the while loop. I'm going to start with the if statement. So if statement is just if some Boolean condition is true, continue. So I'm going to say int I equals 10. If I is greater than 5, out. And I could say, for instance, I is greater than 5. And if I run this, it'll print if I is greater than 5. But as soon as I is no longer greater than 5, it will not. So here is where an else comes in, if else. And actually, I'll make an if else if ladder. So I can say if else if I is greater than 3, out. And then I could say else. I could keep doing this if, else if, else if, else if for a long time. You can go as deep as you want, but I'll stop there. I'll say out, I is less than or equal to 3. So that's an if statement. Basically, inside an if statement, you always need a Boolean condition. It says if, and then these parentheses, that's where the Boolean condition goes. And if that Boolean condition is true, whatever's inside the if statement will execute. And if it's false, it'll skip it. I should mention here real quick, this is a good time to talk about variable scope. In here, I can print out I, this variable I, like it's available to me. But if I declare a variable in here, let's say int q equals 10, and if I go into some other block, q is not available to me. See how it's red? That's an error. If I go there or down here, it's just not available to me. That's because q is in the scope of this one if statement. So what scope of a variable or the lifetime of a variable is defined by its nearest enclosing curly brackets. So this int I, is available anywhere within this main method. And you can see when I click next to a curly bracket, it highlights the enclosing curly brackets of this method. So I is available anywhere in this method, but q is only available inside this if statement. And that's called variable scope. Understanding variable scope is super important. And if I were to declare a variable up here, like int s equals 10 or whatever, s would be available everywhere. For instance, I could say out s here. That'll, well, it's because static. Don't worry about static, we'll come back to that. But now s is available. So this is called a global variable or an instance variable. And then I right here would be called a local variable. It's local to the method. And then this is kind of a hyperlocal variable. It's just available to this if statement. That's variable scope. Okay, that's if statements. So let's go on to while loops. A while loop is basically while some Boolean condition is true, keep looping. So let's say I'll create another variable, int I equals 10, and I'll say while I is less than 10, out I, and then I'm gonna increment, or actually, how about while I is greater than 0, greater than or equal to 0. And then I'm going to decrement I, which is I minus minus. And that's just shorthand for saying I equals I, whatever I currently is, minus 1. Right? That's a valid statement, but you can shorten it by just saying I minus minus. So when I run this, it'll print out 10 through 0 in descending fashion. Because while I is greater than 0, it'll enter this loop. It's going to print out I, and then decrement I, and then loop. Right? What happens if I if I don't decrement I? I've got an infinite loop that hopefully I don't crash my computer right now. It's going to print 10 forever. Fortunately, I can just stop it, since I'm in my IntelliJ. But you can see that if you look at my cursor on the right side, I'm scrolling right now. You can't barely tell, but it printed out thousands and thousands of times already, at least hundreds and hundreds. So when you got a while loop, make sure that you got a way out of there. There's also a do while loop. So a do while loop is just like a while loop. But or actually, I'll put this in the do while class. So that's your while loop. A do-while loop, I might just make a little shortcut here. Don't tell anyone. A do-while loop it basically just says do something first and then check the Boolean condition. So this, and the only difference, the reason why we would use a do-while loop is to ensure that this will get executed at least once. Whatever's in the do will get executed at least once while I is greater than 0. So it just puts the Boolean condition afterwards. Then we've got a for loop. So ESPN. A for loop is when you know exactly how many times you want to iterate, you can just say for int I, and I could be anything else. I'm going to start it at 0, while I is less than 10, and then increment I, and then sout I. So this is very similar to what we've just done, but now it's in a for loop. And a for loop has, and you can see it printed out, 0 through 10 in ascending fashion. I could also say for int I equals 10, while I is greater than or equal to 0, and then I minus minus. I could just run it like that. Right here, we've got what's called the initialization, int I equals 0. This is the Boolean condition, how long it should continue to loop. And then this is kind of the controller, the incrementer, the decrementer, like you have to change it. And this can also say like minus equal 2, which is the same as saying I equals I minus 2. So if I do this, it'll print out 10 to 0, but it'll go 10, 8, 6, 4, 2, 0, for instance. That's a for loop. For each loop requires an array, so this is a good transition to our next array section, which is arrays. Let's say I have an array. You declare an array with square brackets. So this is an array of ints, and I'm going to call it numbers. Equals new, which means I'm creating an object, which we'll talk about shortly, int array of size 10. With arrays, standard arrays, you always have to give it a size. And then I'm going to say for int I equals 0, I less than, and I'm going to use the length of this array, the length variable. So that'll give me, the length will be 10 there. I plus plus. And then I'm just going to say numbers at the index of I equals, let's say I times 3, just to give us something. Now I'm going to use a for each loop. So this is a traditional for loop, and I've just used it to populate this array. Arrays are basically buckets of information that are all of the same type. So in here we'll have the number, it'll be the number 0, and then 3, and then 6, and so on and so forth, 9. But then I'm going to use a for each loop, and it's a little bit different. I'm going to say for each int, which we're going to call I, in numbers. And then I can just say sout I. And this is a little different, so I'm going to run this, and it'll print everything out just like we want it to. 0, 3, 6, 9, 12, 15, so on and so forth. But you can see the syntax is different. This is a traditional for loop, and this is a for each loop. It requires a collection, and an array is a type of collection. And here I is an index, so I'm saying give me the value at the index of I in numbers. So imagine numbers is like it's basically a list, and the indexes. This is all going to be here. I'll put it in comments. By the way, in Java would comment with /*, and to end the comment we say */. So here I'll just kind of visualize an array for you. The index of 0 has the number 456. The index of 1 has the number 123. The index of 2 has the number 90. The index of 3 has the number 76 or whatever, so on and so forth. That's like an array. Array indexes start at 0, and they hold some value. The length of an array is the total number of elements in that array. So the length of this array right here would be 4, but the final index would be 3. This is a funny little thing with arrays because the first index is 0. In Java, in arrays and indexes, we always start from 0. So this is the length of 4. So here when I say numbers.length, this is going to give me 10. But the final index of this array that has 10 will be 9. And so here I is an index, but here I is not the index. I is the actual value. And that's the difference between a traditional for loop and a for each loop. So here with a for each loop, you're basically guaranteed to visit every single element in that array. You can do with it as you please. In this case, we just are printing it out. So in the case of my little array here, it would print out 456, 123, 90, 76. had the array had those numbers in it. In this case, it had these other ones. But so this is traditional for loop and for each loop. Let's talk a little bit more and very, very quickly about arrays. So arrays, as I mentioned, are buckets or collections of similar things. So let's make a double array this time. Double nums equals new double array. Let's say I want to put the value, let's say at the index of, I have to give this a length. Let's just give it simple and keep it to 4. And maybe I will actually use these numbers this time. So nums, double nums at the index of 0 is going to get the 456.1. And I'll just copy and paste for speed. The index of 1, the index of 2, the index of 3 are going to get the numbers 123.2, 90.3, and 76.4. This is how I'm initializing an array, right? And so now if I use a for each loop, for instance, I could say for each double, which we can call n in double nums, out, which is short for system.out.println n. Now when we run this, you can see that those numbers printed out. If you try to do something, for instance, let's say I try to say double nums at the index of 56 equals 56, let's not confuse it, equals 234. I'll just run this again to show you. I'm going to get an exception because I can't put something in the 56th index of an array that only has a length of 4, right? So the only available indexes for me on this array are 0, 1, 2, 3. This is always an index array out of bounds exception, which you can see gets printed out here. We don't like exceptions. Lastly, very, very quickly, array lists. Array lists are just like arrays, but they're more useful. They're a little bit slower. They take up a little more space because they're more useful. So basically, an array list is a generic type, which we'll talk about soon. And I'm going to make it a type of strings. So strings are just like words like hello. And let's call this words equals new array list. With an array list, we do not need to declare its size. It'll grow dynamically. And we've got things like, instead of having to use direct indexes, I can say words.add hello, words.add world, words.add I love Java. And then for an array list is still a collection, so I can still say for each string, which we can call s in words, sout s. So if I run that, it'll say hello world, I love Java, just like that. We can also do things like, for instance, if words dot, and whenever you say dot on a method or an object, sorry, just hit dot. It'll show you all of these methods that are available to you, and what these are will make more sense shortly. But I'm just going to say if words dot contains, let's say world, then print out sout. I think you are saying hello world. So I'll just go ahead and get rid of this for a second. To block comment, I'm going to highlight this, hold down command and hit slash. And it's here we can say, I think you're trying to say hello world, because I use the contains method on the array list. Array lists have these these nice useful methods that arrays don't. So arrays are just very, very basic. There's no methods on them. If you want to deal with them, you've got to deal with their actual indexes. At the index of 0, at the index of 4, etc. Array lists are a little nicer. They've got, words dot, I can say words dot remove something at, like, I could give it the word I want removed, or I could give it the index that I want removed. And they'll automatically shrink and grow as necessary, which is really nice, especially when you don't know how much data you're dealing with. Okay, we made it through primitive data types, variables, operators, flow control, conditional statements, and a little bit into data structures. I know this is fast, but I hope it was useful. In the next section, we will be covering Java classes, objects, methods, object-oriented programming, static versus non-static, and packages. And I hope you can join us.